sometime later they thought, oh, you know, we should just use slf4j. So they deprecate this internal library, and 6 years later, there's still millions of references to this original logging library. It just was never going anywhere. You know, it's what engineer is going to come into work one day and think the best use of my time is replacing a bunch of logging statements one for another. Unfortunately, the change actually looked somewhat complicated. It looked very similar in many ways to slf4j. It looked something like this, like there was actually something called logger factory, get logger, but the actual statement was something like this, where the parameterization was more of like this, like the string format type format rather than the slf4j one. The exception was first instead of last. And, you know, of course, like any code, you know, it varies quite a bit. So this could span multiple lines. You could have string concatenation in the middle of it. It could, you know, be all over the place. So it's definitely something that went beyond the scope of what we could do with like a simple regular expression and actually get it done. And so this was the first thing we tackled with it, you know, to try to change this into something that looks more like this, where we've, you know, updated the literal, we flipped the arguments here, and otherwise we preserved the rest of the formatting of the code. So clearly, to do something like this, we had to be built on an abstract syntax tree of the code. So an abstract syntax tree, of course, is just the parsed representation sort of built into these into this tree-like structure. And it would not have been the first project, you know, to do AST manipulation. But there were a couple special characteristics we felt like we needed. One, that the AST that we wanted to operate on had to have type information. After all, if you're going to accurately identify methods called error that come from our original internal library, you know, we had to actually know that this method call was of that type coming from that old API. And then the second thing is we really wanted to be able to perform these sort of transformations en masse across our whole code base. So we had something like 10,000 repositories at the time. So we wanted that AST to be serializable in a compact form that we could ship off to and work on in batch on the side. Ultimately, Rewrite is built. It has its own abstract syntax tree, which is really just mapped from the Java compiler's own AST, but then also adds all the formatting information, all the white space that occurred before elements, and represents that in a compact way that we can execute recipes on en masse. So let's actually run just a recipe to get kind of going with you know, an idea of what this could be. Like, I'm gonna flip over to this screen here, and hopefully you can see now if I've done this correctly, you can see this screen here with a catalog recipe. Somebody tell me if you can't, but we're gonna go look for some particular recipe. What I'm showing here is our service, our company service, that just takes the recipe, all the recipes that you have in open source, and can run them on code that we have pre-adjusted, like we were talking about. So we're going to go into, say, like cleanup and look for this use diamond operator. You know, at some point in Java 7, they introduced the diamond operator to reduce the verbosity of generics code. And you know, for older code bases, you still see a lot of this. You know, improvement could be made around using this. So it's something simple. Let's run this on some Netflix repositories that we have pre-adjusted and just kind of see what we can do. So here we say, like at the top here, it's made changes to 11 files in the Netflix conductor repository, dropping this type over here where it's unneeded. And you know, we can kind of scroll down and see hash map usage here, array list usage. And so all this looks pretty reasonable to me. It looks like it changed about 11 files, yeah, like I said, all together. So this looks good. I think we're just going to, we can just go ahead and create a PR on this. I have the option here of, forking the original repository or creating a branch in the repository if I'm actually a maintainer of it. But of course, I'm not a maintainer of this one, so we'll just fork it. And so here, you see in GitHub, we've already pushed this to a new branch on a fork that it created for me. All the changes that we saw there in the service. And this looks pretty good, so we'll just create a PR here. Pull request type to say it's refactoring, no functional changes. Basically here we're use the diamond operator possible. Thanks. And that would be it. So that's kind of the first change I think that we could make to something. The same recipe that we just ran over here, this use diamond operator, could be ran locally. So we have a docs page here, docs.openrewrite.org, which shows you how to use. We have Maven and Gradle plugins. These are open source as well. And using one of the Gradle or Maven plugins, you can apply this recipe to any repository that you have. So for Gradle, you would just add the plugin. You could activate this particular recipe and just run rewrite run. And it would just do the same thing we saw there, but it would just make the changes locally on disk. So then you could review them, make any changes that you'd like, and commit them there. So every recipe that we create goes into the open source projects and are applicable via the Maven or Gradle plugin. So some of these recipes, now we just did something relatively simple. We did something like use diamond operator, but it's not always so easy or so. So we've sort of been building on these recipes and adding higher and higher levels of abstraction to the point where you should be able to do things like whole framework migrations, like Spring Boot 1 to 2. And here we'll just find this pet clinic repository that we've pinned back to the old 1.5 release of Spring Boot and run this recipe here. And so here you see that we've not only changed Java code, but actually gone into the POM and made the changes necessary to update versions and strike properties that are no longer necessary, and add new dependencies which are required in Spring Boot 2 and remove ones that you can't have in Spring Boot 2 anymore. And then the code changes, of course, are made as well. So they did something, relatively complicated, like they removed this conditional on being, and now you're supposed to use conditional and create an any nested condition. And so part of what the rewrite AST is designed to do is preserve the original format of the code to kind of detect the style of the original code and make a change that looks idiomatically consistent in the context of the project that it's being ran on. So we don't make any assumptions about, you use tabs or you use spaces or you use, this many tabs or that kind of thing, import ordering and so forth. So the same recipe ran on repositories that look very different could, yield different results. It could keep scrolling down. Auto wired isn't necessary anymore. Here, you can drop the argument on path variable because the parameter name is the same. They made that change in Spring a while back. Sometimes the changes are more essential, or these are really best practices things, like if you use a request mapping in Spring, this actually technically represents a CSRF vulnerability because this endpoint permits access on a delete method or post method or so forth. And really it was intended to just be a git mapping. So we've refactored that as well while we're at it. And so these would be all changes that would result in a running project. So if we look at one of the recipes, so recipes can depend on other recipes and they can sort of build up into these trees of more and more complex things. If we go into the Spring Boot 2 and look at this migration and look at the details of it, you'll see that to go from Spring Boot 2 from Spring Boot 1 involves all of these basic recipes, upgrading this Maven dependency, this one, changing this type, changing this type. You know, and in some cases, it even depends on recipes that themselves have additional options. So maybe like if you click into this one, it would have, you know, it would in turn have several repositories. So it's like recipes are like a recipe tree of higher and higher order concepts as you go down. So some of these recipes you can kind of sense that because we've sort of been building these building blocks, some of them are runnable with just supplying some input. So if I was going to do a change type from one thing to another, I could just supply the old type and the new type, and that would be enough. So I don't need to necessarily learn a whole new like query language or something like that in order to be able to make a change. For the simple things like changing types or changing method names or changing the target of a method, or or ordering imports, those things are all just built with basic building blocks. And in fact, what we permit is the definition of recipes, even in a simple YAML form. You don't have to use this, but you can take basically put a file in a meta-inf rewrite directory of any library that you have and start packing in it recipes. Like in this case, we say we want to change this type to this type. We want to reorder these method arguments. We want to add dependencies if a particular type is in use. These sorts of things. And this YAML could be shipped with the next version of a library, and that would help users of that library migrate from the earlier version to the later version. So this is a behavior that we had started at Netflix, is developers would not do so much deprecation, but rather just go ahead and remove the API, pack the new recipe that involves that helps your consumers migrate to the new thing. And at the point of consumption, the moment they receive that new library, they would get that fixed. So pretty cool capability, I think. Some things are this way. Some things are more complicated. Some things are hard to describe in terms of, change type or change method name. I think I mentioned one of those a little bit earlier, which was, you've all seen the pattern where you have a try-catch block and you have, say, throwable.print stack trace. What if I wanted to turn that into a logging statement? So first, we're going to go over here for a moment, and let's just look and see what we've got. Maybe let's look for find methods, and we're going to look for java.line.throwable, and realistically any of its inheriting classes as well. And we're going to look for print stack trace. And there's no argument types or arguments to that, of course. So let's just select everything here and just run it on everything. We've got about 30 million lines of code here that we're working on tonight. So you can see how this special AST that we have in the open source product helps us to operate on like a massive amount of code in a reasonable amount of time. Here you see, this is not any surprise. You're going to find in a lot of these open source repositories a number of these situations where you have somebody's just said print stack trace, as opposed to doing anything else with it. One of the really cool things, actually, that I think is worth pointing out here is we just did a search. So we did a search for a method, and the way we see it, because we're all about really making changes, we really see search as just a special case of transformation. So when we do a search, we actually add a little marker to that AST element, and then you can really just render that marker in different ways. Like in this case, we just rendered it as a comment that puts an arrow pointing at the thing that you're trying to do. But you can imagine, trying to locate something and rendering the marker as like a to-do or a fix me or really anything you could think of to sort of reify it and make it real. And once we've done that, we can pass that AST through the regular Git diffing engine, and we see results like this, just like as if we had made changes. So, not too surprising. We see exception, print stack trace here. So you can see that we were able to find subclasses of throwable in addition to just the base throwable type. These are going to all look pretty similar. So let's maybe set about to create a recipe here that would help migrate you from this to, using a logging statement, if such a thing is there. So I'll head over to the IDE now, and we do have a project called Rewrite Logging Frameworks. It contains things like log4j to SLF4j migration, which are useful as well. But I feel like that's a good home for this recipe. So we'll just add it here as a new base recipe. And this one obviously is a bit more complicated. So we're going to create a programmatic recipes, and we're just going to call it print stack trace to log error, which is what we're trying to do. And here we'll extend recipe, which is a rewrite type. And we have to implement this display name. So we'll say use a logger instead of print stack trace. And maybe we'll add some description text here, which will say when a logger exists or is available, log an error as opposed to just printing the stack trace. So that's just some basic metadata, and that shows up realistically over here. So this information here, this display name, description, this is what we show in the Maven and Gradle plugins when you sort of look at the recipes that are available to you. It's what we show over here when we are just browsing around looking at various things. It winds up being the name of the individual recipe in the description here. So these are just generated automatically based on this information here. And here we're going to create a visitor that can perform this change. So I think AST visitor is what we're really after here. This is Java code that we're visiting and changing, so we'll make that at the type. And so really what we're after is changing a method invocation. We're changing e.printStackTrace to some other method invocation realistically. Sorry, I got the wrong type here. So we'll visit that. And the first task, I guess, would be to locate cases of where print stack trace is called. So we're going to create a method matcher here. And it's very similar to what we just did in the service over there. We just want to create a java.lang.throwable print stack trace. And here we're just going to test whether this method, so it prints if print stack trace, or sorry, yeah, if print stack trace that matches this method, then we're in a place where we might do something. But first of all, we might do something here. But first of all, we only want to replace these print stack trace methods if there's a logger that's actually available. So let's look for. So we're in the method invocation. So maybe let's write the test first, so it's more obvious how this would go. So stack trace to log error test. And here we've got a unit test harness called Java recipe test. And we'll say replace print stack trace. So we've got a method on Java recipe test that allows us to just assert whether something was changed. So we're going to have some like a before and after piece of code here. Let's specify the recipe. The recipe that we're trying to run on here is print stack trace to log error. That's the recipe that we're operating on. And so we've got some code here, and maybe like we'll say import org.slfj.logger and class test. We'll just create a logger field here. And suppose we had a method where we just had a try catch block in it. And we were just saying t.print stack trace here. And what we want after we're done with this is for this to instead be something like logger.error exception t. That's really what we're trying to achieve. So some things to note about this unit test. We really focus quite a bit on trying to make these things easy to write. And so we actually use this annotation that IntelliJ makes available on the unit test to see like this language Java, so that IntelliJ will actually syntax highlight the text of the test for you and help you write the code inside of that. So that's pretty cool. You get to do that sort of in line. Now this test in particular uses slf4j, and so this test is going to use the compiler, actually the Java compiler, to compile this piece of code into an AST and then make changes on it. And so we need to tell that compiler that it needs a new dependency, because the default one just doesn't have any dependencies on it. So we're going to say Java parser dot just whatever the Java version is that's running this thing. And I'm going to look for an slf4j API dependency here in my runtime. The runtime of the test here that's actually running. So this is going to help this parse this correctly with the logger type, everything on it. So that's kind of the before and after. So again, we've encountered a place where we've now matched this print stack trace. If we went over here, we've matched that we have a this actual method, but we only want to make a change if there's a logger field failed. Otherwise, we don't want to try to change it. So the next thing we would want to do here is, if we're inside a method invocation, what I'm expecting to find is a logger on the enclosing class as a field. So let's look at the class declaration that's above me. And there's this thing called a cursor, which just maintains a stack of all the elements that I've seen before getting to this method invocation. And so I'm going to look for a class declaration above me. And so this is the class that contains me here. And what I can do is I can look for fields like on this class. And I'm going to look for slf4j.logger fields here. Maybe we'll keep these for a moment here. And we'll say if loggers is empty, if they're not empty. Now we really know we want to make a change, right? We've actually identified this is the place to make a change. So now the next task in front of us is really to generate this whole piece here, this logger.error. And for that, we can use a mechanism we have called Java template, which allows us to just basically write the thing that we want as regular Java code and have it, automatically built into an AST that we can then insert in place here. So maybe we'll call this the slf4j error, and we'll build one of these. So we can, the first argument is a cursor, so it's going to need the cursor sometime. We'll give it that. And then the text that we want is really something like logger.error exception. and then, whatever the name of that thing was. So that's sort of what we're after. But of course, we don't really know what the name of the logger is, right? It could be different from every class, from class to class, and we don't know what the name of the actual throwable is. So that's also something that could vary from class to class. So we're going to create this basically parameter, and it looks very much like a matcher from Mockito or something like that. So we're going to say any SLF4J logger is acceptable here, and any Java.lang.throwable is acceptable here. So now we've got something that's kind of getting closer to what we would like. So let's take this down here and actually use it. We'll say that we want to take this method that exists right now and just altogether change it. We're going to say with template, and we're saying this is the template I'm going to use, and now I'm trying to target it at something. And the target in this case, there's a coordinate system. I'm going to say I'm just trying to replace this whole method. So and with that, there's some parameters, and the parameters I'm going to use here are going to be like I'm going to look at the SLF4J loggers that I already identified, and say like iterator.next. Now this variable declarations up here represents a whole statement like this, potentially with some things like this. And as you know, like variables can contain multiple variables here. Like they could in certain circumstances they could look like this. So we're just going to get the first one and get its name, and that's going to be a substitute for this logger here, whatever the name is that we find. And for the second argument, we're just taking the method and it's select. So if you look at the method t.print stack trace, this portion is the select, this portion is the name, the arguments. So we'll just take that, and that's what we can use as the parameter. There's sort of, let's try to run this for a moment and see what we see. Okay, so it ran, but it said at the end that the statement that we generated of logger.error was missing types on it. So in other words, the abstract syntax tree itself, like it didn't know how to put a type on this, and it didn't know how to put a type on this. So it generated the right code. And if we just did maybe suppress, what is it called here? Skip. We just did this, like skip this type validation. And we would see that it does work. Maybe I'll show you what happens here if it doesn't work. So maybe this isn't the text that I actually generated in there. So we'll run this one more time. And so looking at the diff here, you see that the only difference here is the exception 2 as opposed to exception. So there's a ability to quickly see how close you got to what you wanted. Okay, so this type validation thing, obviously the code here was correct, and if we generated a diff off of it, everything would be good. It would compile, everything would work. But we like to ensure that when we replace things in code, that it does have the correct types on everything, because you could be running another recipe afterwards that would look for look for further occurrences of logger.error, for example. And so you want to make sure that a follow-on recipe is able to do that correctly as well. And for this, we just have to note that the Java template here is itself using the Java compiler in order to compile the stub that we just created here, this like logger.error exception with a T. And so we can add this, we can influence the actual class path of that Java parser there. And to it, rather than actually having to add a dependency to the runtime here, it's usually good enough for us to just stub out the thing that we're trying to add a type for. So like org.slfj.logger, and it's like public interface logger. Sorry, the package is just org.slfj. And the actual type here, or the method, is like void error string message throwable T. And that, I think, if I type this all correctly, I think will be enough to get it compiling correctly. Yeah, so this all tests out now. This recipe was able to turn this t.print stack trace into logger.error. I was able to respond to the actual, we could change these here, to the actual variable names in the context of the project that I'm doing this in. So if we change all these to log, you should see the change here. And everything looks good there. And we could keep expanding on this. We could expand on it to include, to respond to, say, like log4j loggers, for JUL loggers, and so forth, to kind of expand the scope of this recipe. So I've taken this. You see that we've got rewrite logging frameworks here. It's just a Java project, and we could package this up as a jar. If we hop back over to the service, we you can basically deploy different recipe jars to the service itself, and then run them. So of course, just like a regular cooking show here, I've sort of like pre-baked this one. I've built this already and uploaded it to the service so that we could see what would happen if we ran this recipe against, all 30 million lines of code. And here's the recipe that we basically just wrote. Use logger instead of print stack trace, and we'll run that on everything. So start looking at some of the results as they come in. This one drill has just got one. Yeah, you can see here where we changed e.print stack trace into logger.error. We've got like, clips here. Here in this class it was called logger, and this one it was capital logger. This was called log. It's just very different from place to place. So here's an interesting scenario where I think and this is what I like about taking these recipes, writing unit tests for them, and then running them en masse across lots and lots of code, is you start to see things like this we didn't anticipate. Like, what if they logged something already and then they decide to print the stack trace? So we could basically go use that same cursor messaging system, or that cursor, and say, look up to the catch block around me, and if I've already got a logging statement, don't do anything. So that could be a little bit more sophistication we add to the recipe that we didn't have already. But it's kind of that. So outside of the ability to migrate Java code itself, of course, this is a Java meetup, and we have a lot of focus on Java. We added like YAML and properties and Maven, because if you're going to say move from Spring Boot 1 to 2, you also need to go and change your properties files, and YAML to reflect all the new property changes they made. But recently we've been adding things like Terraform as well, where we can look at, say, like the TerraGoat repository here, and run these this recipe here, and ensure that you have like image scanning turned on ECR pushes, and the security right on AWS instances and so forth. So turning on SSE when possible, and so a lot of interesting little things that are possible. You see here that there were basically 3 independent recipes that made changes here to this one Terraform file. So and that's I think I'll stop here for a little bit and just open it up for discussion. So I don't know if we can sort of allow people to unmute themselves at this point, Courtney, or that would be.
Yes, and it looks like people are already popping in the chat, so you guys can
okay.
that. But if anyone wants to unmute, feel free to ping me in here, or you can even, I think you can ask to unmute and it'll pop up on my screen.
Oh, okay. Yeah.
I think so. There's those options.
Well, I'd certainly love to. We can start with the Non's question there. Are you planning to expand the compiler bindings to other JVM languages like Scala and Clojure? I see Kotlin on the GitHub repo. So we do plan to expand, yes. Probably the first JVM language we'll go into outside of Java is Groovy, which seems a bit old in some ways, but the goal here is to quickly support Gradle dependency remediation and other plugin updates and so forth. And we know that the majority of Gradle build scripts are still written in Groovy in the wild, so we're going there. And it's just a fascinating story in its own right. You think that this sort of type-aware, high accurate change would be very difficult to do in a language like Groovy, where it's dynamically typed. But our friend Cedric years ago wrote a static compiler for Groovy that is only supposed to run when you have a compile static annotation on something, but we found that you can basically just force it to run, and it does a pretty good job of even type attributing Gradle code to the point where I think we could make very accurate suggestions even in Gradle builds to update them. And so from there, of course, going into Kotlin, and so that would be, that's kind of the direction there. So Ted asked a question here, and he's about, is it possible to have tests run after each recipe to catch things before further changes are made? And that's an interesting question. Maybe you could elaborate on the case there, Ted. I know you've been.
Ted, I'll go ahead and unmute you if you don't want to.
Oh. If he's around. We may have put him on the spot there.
I know. Sorry, Ted, feel free to type also. My mic doesn't work.
Oh, his mic doesn't work. Okay. I think with the current unit test harness, you saw where you're able to select the recipe that you're running, and so I suppose you can sort of run each one in isolation. You can do like you could sort of do like something like this, where I've parents, yeah. So display name would be, I don't know, here, and I'm trying to remember the syntax here. I think, yeah, dude. So recipes can just be composed of other recipes, and that's that's all that they do. They don't actually take any action on their own. And to do that, to chain recipes together, you just call do next anywhere, and so some recipes actually have visitors in their own rights, and some of them like and some of them just omit it altogether and chain them together. So I suppose you could write a test that does, this, then this, and, and test that, that those collaborated together well.
And John, I think he did elaborate on that a little bit in the chat.
Oh, okay, let me stop sharing here. My applications test. Oh, I see, to run the applications test. I see. That's interesting. I suppose you could do that with the Gradle plugin by creating different tasks that like ran one recipe, then then chaining, then run the test, then run another recipe, then run the test, and so forth. That's it'd be interesting to see that put together. Yeah, I don't think we've done that specifically. Yeah. Yeah. Yeah, thanks, Ted. So yeah, would be happy to hear what other thoughts are. Like, it's hopefully a pretty new thing, this idea of being able to transform code rather than just kind of search for problems. So interesting space.
Awesome. Well, if anyone has, oh, we got another one. Daryl has a question.
Yeah. So the API looks really nice. Daryl says, what was the design process? Slow. It's been a while. So it started in 2016, like I said, and the actual, there's a lot of similarity, and not unintentionally, between the types that we actually see here, like method invocation and all of the data elements on it, and what's it called? JC.method invocation, I think. What's it called? So the actual compiler internal elements are very similar, and so again, we go through a mapping operation where we take the compiler through its first two phases of compilation, the parsing and type attribution, kind of pause it, and then map it to RST. So there's a lot of the OpenJDK compiler is really well done, and a lot of take a lot of influence from that. And then everything else, it's been a process. We originally started with only being able to build AST elements by hand, but that can get really complicated. So we built a templating mechanism and just kind of going from one thing to another as we try to build. Andreas asks, this looks exciting. Is this free of cost? The OpenRewrite, the actual core refactoring engine, is open source and always will be. That's it's against here on GitHub. OpenRewrite rewrites Apache license. So this contains the abstract syntax trees, all those core recipes that you saw there. Most of the recipes around, like upgrading Spring or testing for JUnit 4 to 5, assert to assert J, all those kind of things are here as well. The service that we showed tonight is something that we've been ingesting a bunch of public repositories on, and public open source repositories, and we're inviting people privately to come join that and just test it out. Test running recipes on things. We've had people issue PRs to like Netflix repos or other repos, based on just tinkering around. And we'd love for you to join us there. We just ask you just go to basically moderne.io here. Just drop your email here, and we'll get you into that. And as we go through that process of like iterating on that UI, eventually we'll just open that up for anybody to log in with GitHub to operate on open source repositories. And then, of course, for us to survive as a company, we want to operate on private code as well. And that's where, that's a different story in terms of how we ingest those things and so forth. And for that, if you do have internal framework migration, you're trying to move to JUnit 5, you're trying to move, the latest Spring, you want to auto remediate check style stuff, we'd love to talk to you and help see if we can make some changes and fixes now as well. So for sure, reach out. Yeah.
All right, we'll give everyone just a second more. Oh, yep, got another comment.
Yeah.
Okay, well, if anyone else has a question, go ahead and pop it in now. Otherwise, thank you so much for an awesome presentation, John. That was amazing.
So
we have another one.
Yeah, it looks like Deepak has something. In this case, in case new framework introduces a project. Maybe you could come off mute for a moment, Deepak, and explain that a bit more to help understand.
I'm asking
Hey,
to
Jonathan.
Hi, I see. Yeah.
Quite often the API gets changed and the new frameworks being introduced by new team lead or new management. That's what I faced all the time, and it's difficult to change on the fly, and business they need quickly. So yeah, this might help.
Yeah, for sure. Yeah, I think I described something earlier, which was around, just taking, when you're about to make a change, you could pack the recipe in the new version of that component and ship it. And so those Maven or Gradle plugins can just basically scan the class path looking for available recipes and run them. So that's a pretty exciting way, I think, to distribute change to help people migrate, as opposed to just writing a guide or sending a bunch of emails or something like that. So it's really cool.